Hey guys, hey guys, welcome back to my channel. Uh, uh, Today we are going to solve problem of the day in Geeks for Geeks. Today's question is check if frequencies can be equal. Uh, you guys also read the question once. When I am reading, check if frequencies can be equal. Given a string S which contains only lowercase alphabet characters, check if it is possible to remove at most one uh, character from the string in such a way that frequency of each distinct character becomes same in the string. Return true if it is possible to do, else return false. And the driver code print one if the value if the value returned is true, otherwise it is returns 0. Here we have to solve this problem in O of 1 space complexity, O of S time complexity. Here the S range up to 10 power 5. So guys, here question actual meaning is, for suppose if here A B B A, so here at most we can remove at most we can remove one character and at least 0. Here means here already all characters have same frequency. Here already all characters have same frequency. So here if for suppose what for suppose x y y z, if the string is like this, if you remove one y occurrence of one time, then the string is become xyz, right? So here that all the frequencies is same. So the problem statement is like that. At most we have to remove one character from the string, and that frequency after removing that, frequencies of all the characters should be same. So I will give one more example. For example, a, here we no need of remove any character. So here we can directly return true. Here no need of check all of these things. So for suppose a b, here the frequency of a is frequency of a is 3, and frequency of b is 1. So here the at most we can remove one character, right? So become all the frequencies of the characters, all the character strings becomes what if you what means if you remove b here, then a frequency is 3, so we are removing one character from this, so a frequency is equal to 3. So all the characters have the same frequency here, right? A character is 3 means only one single frequency. If we are removing here 1, so in the what we are doing is we are taking one vector here that size is 26, means we are using 26 sized vector here, means it is almost equal to O of 1 space complexity. It is not a O of n time space complexity, it is O of 1 space complexity. So what we are doing is yes, so what we are doing is we are finding the frequencies of all the characters in this vector, and then uh, uh, what I am doing is I am adding all the frequencies. And I am checking what I am adding all the frequencies. I am checking, and I am checking the frequencies which is not equal to 0. I will give with one example. For suppose x y y z, here the x frequency is 1 and y frequency is 2, z frequency is uh, z frequency is uh, what z frequency is 1. So here total number of characters here are distinct characters are 3. So I am adding all the frequencies. Here I am adding all the frequencies. What so all by adding all the frequencies 1 plus 2 1 it become 4. So total number of distinct characters are 3. So minimum characters, minimum frequency is how much? Minimum frequency is 1. So I am multiplying 3 plus 1 is equal to 2. If it is comes like this, or 3 into minimum frequency. Minimum frequency means total number of characters into minimum frequency is equal to total sum. Total sum is this sum. I will give one more example. A B B B. Here what D. For example, A frequency is 3, B frequency is 3, C frequency is 3. Here minimum frequency is uh, 3, right? And total number of distinct characters are 3. So I am adding all the frequencies. Initially I am adding all the frequencies. So total frequency is sum. I am storing that in a sum. So it is 9, and I am multiplying distinct characters into minimum frequency. I am multiplying distinct character into minimum frequency plus 1 if it is possible, if it is equal to sum, or multiplying distinct characters into minimum frequency. This case possible to this means just multiplying minimum frequency with total number of distinct characters. So total number of distinct characters are 3 and minimum frequency is 3, so 9. I will give one more example. For suppose A B C D. Here distinct characters are 4. Distinct characters are 4 and minimum frequency is 1. We have to multiply 4 with the minimum frequency. Distinct characters into minimum frequency. If it is equal to total sum of all the frequencies of character, sum of all the frequencies of character is 4 here. So 4 is equal to 4. How I got this thought, why we are doing in this method means, this is very simple idea. If it is we have to check like x y z, right? So if all the we have to make the frequencies, all the frequencies are same. So I am taking the minimum frequency. If minimum frequency, we have to make all the frequencies are same. Like for suppose x y and z. So x frequency is 2, y frequency is 3, z frequency is 2. Here minimum frequency is what? We have to make this string to all frequencies are same, x y z. So I am considering the minimum frequency into total number of distinct characters. So after removing that one distinct character, it comes like this, right? So plus 1, I am adding all the frequencies, initial frequencies, so it becomes what? 7. And plus 1 means that removed character plus 1 is equal to 7. So here it is possible. We have to check it is in the possible. This case also sometimes that is automatically what? That is already a perfect string, means all characters are same. In that case 2 into 3 means 2 into 3 is equal to sum. So we have to add the sum is here, sum 6 here 6. So it is possible. So we have to check, we have to calculate the distinct frequencies, then we have to check these case and this case. You will understand more better by the code. So I am taking vector of temp. Here I am considering int n is equal to s dot size comma for n I plus plus temp of s of I minus a character plus plus. Okay, now yeah, now what I am doing is I am adding all the frequencies. Here I is equal to 0, I less than n, I plus plus, I plus plus. Now what I am doing, dp of I is not equal to 0, then I am adding and I am taking one count variable. Here count variable is uh, dp of I here count plus plus. Here we are adding total frequencies and I am adding count variable. Here I am taking incrementing each time count variable. And what I have to do now I have to check if sum plus, and one more thing I have forgot here, into minimum frequency for suppose into max frequency is into max, so each time min of frequency is equal to min of frequency comma dp of I, min of frequency comma dp of I. Then what I am doing is I am multiplying minimum frequency. Why I am considering minimum frequency here? Why I am considering minimum frequency means for suppose if x y y z, if x y y z is here to become, after removing this character y x, it become y x y z, right? So minimum frequency is 1, right? So minimum frequency I am multiplying with minimum frequency, not maximum frequency. Maximum frequency here too I am not multiplying with maximum. I am multiplying minimum frequency into total count, and minimum frequency to total count plus 1 is equal to sum, or minimum frequency into count is equal to sum. If these two cases satisfies, I am returning true, otherwise I am returning false. So here frequency, let's suppose it is minimum frequency. To more better understand, I am doing this minimum frequency into count, plus 1 is equal to sum, or minimum frequency count is equal to sum. These two cases I am returning true, else I am returning false. Yes guys, this is our question. Here we did wrong, sorry, we are not declared dp, right? Sorry, it is temp. temp. Sorry, here temp, and here also it is temp. I forgot. Yesterday I solved a DP question, right? Previous pivot is DP, so I did this, like I am remembering that only. Yeah, I'm submitting this code. It doesn't satisfy last test cases, or that uh, minimum frequency. Here, sorry, here I have to take up to 26 only. Here I have to take one up to 26 only, and here also I have to take only up to 26 characters, because we have 26 distinct characters, right? No need of do all of those characters. No need of take all of those. Only 26 characters we have to consider. Now I am submitting this. It satisfies all test cases. It passes all test cases. Here the time complexity and space complexity are space complexity is here what to traverse the array, uh, we pass it to up to n, and for 26, so here the maximum time complexity is O of n, and space complexity is 26, means it is approximately equal to O of 1. So this is our solution, guys. If you have any doubts, please ask me in the comment section, and please do subscribe my channel, and please do like my video, hit a like button. It motivates me a lot to do next videos. Thank you, guys.